In this example, we are going to find the exact value of each of the following in radians. As a reminder, when working with the functions of arc sine and arc cosine, we have to be intimately aware with what type of values we can have as an output, or what the ranges of both arc sine and arc cosine are. Arc sine has a range of values from negative pi halves to pi halves, whereas arc cosine has a range from 0 to pi. I have here representation from the textbook corresponding to what quadrants that would refer to in the unit circle. You will see very commonly I say that arc sine is defined for values in quadrants 1 and 4, and arc cosine for values in quadrant 1 and 2. That would correspond to the ranges of each of those functions. What this means is, for example, for arc sine, no matter what the input I have for arc sine is, I cannot output a value such as 2 pi thirds or 5 pi fourths, because those do not exist within the range of arc sine, it being, again, negative pi halves to pi halves. So, for example, if I want to work with arc sine of 0, what that is really asking is it's asking for an angle measure of theta such that sine of theta would equal 0. Keep in mind that even though that happens in the unit circle at both radian value of 0 and also at radian value of pi, the only answer here is 0, because the value has to fit within the range for arc sine. And this has to be between negative pi halves and pi halves. Pi does not exist within the range of arc sine, so it is not a possibility for a result. Same for arc sine of 1/2. Yes, this is really having you think about what angle measure for sine would give you a ratio of 1/2. In the unit circle, that happens a couple times, and it happens at infinitely more amounts of times past that if you consider coterminal angle measures. But since arc sine is itself a function, we should only have one input, and we should only have that one input that would exist between negative pi halves and pi halves. The way that I recommend thinking about this is, first, look at the value inside of your inverse function. If it's a positive value, you're going to get something in quadrant 1. If it's negative, for arc sine, we're going to get something in quadrant 4. More specifically, between negative pi halves and 0. In this case, we have a positive value, so I'm going to get something in quadrant 1. And where sine of theta would equal 1/2 in quadrant 1 would happen at pi over 6. We say that in the representation down here at pi over 6. Remember that sine is associated with the y-coordinate on the unit circle. For arc sine of negative 3 root 3 over 2, in this case, the input, the inside, is negative. That means it's going to be not in quadrant 1, but the other quadrant for arc sine is quadrant 4. We're going to get something down in quadrant 4, more specifically between 0, or between negative pi halves and 0, not between 3 pi halves and 2 pi. Where sine would equal root 3 over 2, if you even look at the representation down here as a reminder, that happens at negative pi over 3. That's where the y-coordinate is equal to negative root 3 over 2. The answer is not 5 pi thirds. Even though 5 pi thirds is technically in quadrant 4, 5 pi thirds doesn't exist within the range of arc sine. It's the same reason why other coterminal angle measures of negative pi thirds would also not be accepted. So 5 pi thirds wouldn't be accepted, 11 pi thirds would not be accepted, 17 pi thirds, etc. Only this one result. If you prefer for arcsine, though, because it is odd, you could also consider using the fact that since it is an odd function, we can rewrite this as negative arcsine of square root of 3 over 2. That allows you to evaluate the quadrant 1 angle measure for arcsine of root 3 over 2, and then make the answer negative. You could do that for arcsine because it is odd. Lastly, we have arcsine of 1. The only place that happens between negative pi halves and pi halves is at pi halves itself. So, arcsine would equal 1 here at pi halves. My answer for that is just pi over 2. For the values involving arc cosine, arc cosine, on the other hand, is not between negative pi halves and pi halves. Arc cosine is defined for values from 0 radians to pi radians. So we're going to do something similar. If it is positive ratio that you're working with, it's in quadrant 1. If it's negative, it's going to be in the other quadrant. In this case, for arc cosine, that means quadrant 2. So, for the first one, though, for just arc cosine of 0, that's where cosine of theta would equal 0. And again, even though that happens a couple places in the unit circle and even more beyond that if you consider coterminal, we only want the one answer that exists between 0 and pi. And on the unit circle, that happens for cosine at pi halves and also at 3 pi halves. The only one between 0 and pi is pi halves. For our cosine of negative square root of 2 over 2. Arc cosine is not odd, so you can't do the trick I was mentioning earlier for arcsine. For this, note that because it's a negative ratio, that means that we're not looking at quadrant 1. We're going to be looking at the other quadrant for this inverse function, which for cosine is quadrant 2. So we're looking over here in quadrant 2, where cosine, the x-coordinate, is negative square root of 2 over 2. That happens right here at 3 pi over 4. That's my answer here, 3 pi over 4. For arc cosine of square root of 3 over 2, that ratio is positive. That means that we're just looking at quadrant 1. So in quadrant 1, where cosine equals square root of 3 over 2. And that happens at pi over 6. Where the x-coordinate there is square root of 3 over 2. The last value we have here is arc cosine of negative 1. Again, this happens really only one time within the unit circle, but there are an infinite amount of coterminal angle measures beyond that. The only one between 0 and pi, however, for where cosine is equal to negative 1, is at pi. Those are our answers for this example.